Good evening all. Okay, now continuation with the topic. See here 28th question. Where voltages are high and current to be interrupted is low, the breaker is preferred is option A air blast circuit breaker, option B oil circuit breaker, option C vacuum circuit breaker, option D any one of the above. Okay, for high voltage applications, the preferred circuit breaker, that is greater than 1 kilowatt, the preferred circuit breaker is vacuum circuit breaker and SF6 circuit breaker. Okay, most preferred circuit breaker is SF6. In this option SF6 is not there, right? Hence vacuum circuit breaker is correct. Next, 29th question. For a rural electrification in a country like India with complex network, it is preferred to use dash circuit breaker, that is option A airbag circuit breaker, option B oil circuit breaker, option C vacuum circuit breaker, option D minimum oil. MOCB is nothing but minimum oil circuit breaker. Again same, in India means high voltage applications, right? High voltage applications we need to use vacuum circuit breaker, right? That means 29th answer is C. See the answer. 29th one is C. Next, the current chopping tendency is minimized by using the SF6 gas at relatively. Okay, SF6 gas is having a low pressure and low velocity. Okay, now see the options. First one is high pressure and low velocity, right? That is not correct. Second option, high pressure and high velocity, that is also not correct. Third option, low pressure and low velocity, that means third answer is correct. Okay, next, 31st question. The SF6 gas has excellent heat transfer properties because of, okay, SF6 gas has higher molecular weight, right, and low viscosity, right? That means first option is higher molecular weight, that is correct. Second option is low gas viscosity, second option is also correct. Third option, higher dielectric strength. Okay, when compared to the, this is also maybe 50%. Next, option D combination of A and B, right? That means option D is exactly correct. That means third first answer will be D is the correct answer. 31st one, right? Yes, 31st one will be D. Next, 32 question. A fault is more severe from the viewpoint of RRV if it is a, okay, if it is a short line, okay, if it is a short line, right, if it is a short line fault, then the fault is more severe in point of RRV. RRV is nothing but rate of rise of restriking voltage, right? That means answer is first option, short line fault. Okay, next, the most suitable circuit breaker for the short line fault without switching resistor is, okay, the most preferable circuit breaker for short line fault without switching resistor. You can underline this point, without switching resistor. Without switching resistor, most preferable circuit breaker is SF6 circuit breaker. Okay, suppose if with switching resistor, the preferable circuit breaker is minimum oil circuit breaker. Okay, next, the voltage at the two ends of a line are 132 kV. That means V1 is 132, V2 is also, that means sending end voltage is 132 kilovolts, receiving end voltage is also 132 kilovolts, and its reactance is 40 ohm. The capacity, that means P maximum. P maximum is equals to, directly you can write EV by X, right? P maximum, that value is nothing but EV is equals to V right here, that is 132 square divided by 40. Okay, now see the solution for that problem. Power P is equals to, I can write directly V square by X, that is 132 into 132 divided by 40. Okay, if I simplify that equation, I will get the answer as 435.6 megawatts is the answer for this problem. Okay, that means first answer is correct. Next, an overhead line with series compensation is protected. Series compensation is nothing but a series capacitor. Okay, because of that series capacitor, what happened? Stability will be increases, right? 35th question, because of the series combination, steady state stability will be increases. See here, power P is equals to E into V by, in denominator XL minus XC will be increases, right? XL minus XC value is decreases, right? That means power is increases, right? But what is the first option is given? That is not protected by impedance relay, that is not protected by reactance relay, that is not protected by Moore relay, right? Okay, those relays are used in protection of transmission lines only, right? Hence the answer will be none. Next, the typical value of a SCR for modern alternators. Okay, SCR is nothing but short circuit ratio. SCR value will be in the range of 0.5 to 0.9 for cylindrical rotor alternators or turbo alternators. See here, I can give the SCR values here. SCR formula will be 1 by ZS, that is synchronous reactance, that is equals to, if I consider only reactance, that is equals to 1 by XS. That SCR value is varies from 0.5 to 0.9 for cylindrical alternator or turbo alternators, whereas that SCR value is 1 to 1.5 for salient pore alternator. That value is 0.4 for synchronous condenser. Okay, now see here, from the given options, SCR value is, fourth option D is 0.5, it lies between 0.5 to 0.9, right? Hence 36th answer is D. Now check the answer. 36th one will be D. Next question, 37th one. In case of large size alternator, the voltage control becomes serious. The voltage control becomes very serious if SCR value is low. If SCR value is low, then only the voltage control becomes serious. That is 37th one will be B is the answer. 37th one is B. Next, 39th question. Sorry, this is 37th, right? Next, 38th question will be, a large size alternator is protected against overloads by providing temperature sensitive relays. Next, the impulse ratio of rod gap is, this is also a direct question, between 1.2 to 1.5. okay, next question, the shunt compensation in an EHV is resorted to. Okay, shunt compensation is nothing but a shunt capacitor or shunt inductor, right? By using that device we can improve the voltage profile. By using series compensation, stability will be improved. By using shunt compensation, voltage profile is improved. That means 40th answer will be C. Okay, 40th answer will be C. Next 41st question, in order to have lower cost of electrical energy generation, right, the load factor, first option is load factor and diversity factor should be low, right? Next, second option, load factor should be low but diversity factor should be high. That is also not correct. Load factor should be high but diversity factor should be low. That is also not correct. Fourth option is load factor and diversity factor should be high. Okay, 41st question, load factor and diversity factor should be high, but load factor value always less than 1, diversity factor value always greater than or equals to 1. Remember this point. Okay, that means in order to get lower cost of electrical energy, load factor should be high and diversity factor should be high. Okay, next 42nd question, the insulation of modern EHV lines. Okay, modern EHV lines, right? Lines are classified into high voltage lines, extra high voltage lines, modern extra high voltage lines, extra high voltage lines, right? Modern extra high voltage lines, in between the voltage range is in between 220 kV, approximately 132 to 220 kV. Those are nothing but modern, right? That means 220 to 400 kV lines, or up to 400, 220 to 765 kV, up to 765 kV, also known as modern EHV lines. Okay, those lines insulation will be majorly decided based upon the switching voltages. Okay, next, that means 42nd answer is B is the correct. Next, 43rd one, the size of conductor on modern EHV lines is obtained based upon modern EHV means again more than 220 kV voltage, 220 above 220 kV and below 765 kV, right? Above 220 kV, corona is depends upon area of cross section, right? That means that depends upon size of conductor. Corona loss is, we need to give priority to the corona loss. Hence, the size of conductor in modern EHV lines is depends upon corona. That is third option, right? Next, 44th question. A more relay is a, I think same concept already covered in starting topic, right? By using equation, that is universal torque equation, right? That is, see here, universal torque equation, torque T is equals to K1 I1 square plus K2 V2 square plus K3 Vi cos of theta minus T plus K4, right? 4 units. First unit represents current unit, second unit represents voltage unit, third unit represents directional unit, fourth unit K4 represent spring unit, right? For impedance relay, K1 is positive, K2, that means current unit is present, voltage unit, right? V by I is nothing but we will get impedance, right? That means where we are assuming first K1 is positive, that is K1 is produced by operating force, K2 is produced by resultant force or restraining force. Okay, restraining force value is always negative, right? Now see here, always you can consider negative to positive. Okay, for impedance relay, K2 value is negative, right? This negative term indicates voltage unit, right? That means voltage restrained, K2 is voltage, right? Voltage restrained over current relay in case of impedance relay. Similarly, in case of reactance relay, K1 value is positive, K2 is 0, K3 is negative. We are considering K1 and K3 values, right? K3 is nothing but third term that indicates directional unit, right? Okay, K3 is negative, right? That means first we need to consider negative term, that is directional restrained. K1 first term indicates current, right? Directional restrained over current relay. For reactance relay, the relay used is directional restrained over current relay is used. Next, in case of more relay, we can use, see here we are considering K2 and K3, which value is negative? My consideration K2, that means voltage, right? That means voltage to directional unit, that means voltage restrained directional relay. In the given question, more relay is given, right? That is voltage restrained directional relay. That is 44th answer is A is correct. Okay, next 45th question. For a stability and economical reasons, we operate the transmission line with power angle in the range of, okay, the power angle always in the range of around 30 to 45 degrees. That means second answer is correct. Okay, remaining we will see in next class. Thank you all.